So at Centaur, very broadly, we're trying to make high-performance x86 processors. It's very, very complicated. You've got millions or billions of transistors on a chip. Nobody knows where they all go. But you can break it down into discrete, tractable problems.
So there's architecture, people deciding what we build.
Kind of start out with the requirements.
Start out with an idea.
What kind of processor you want to build? Do you want it to be big? Do you want it to be small and power efficient? Do you want it to be lean and mean, which is a lot of what we build here?
The architecture then leads to microarchitecture, and the microarchitecture gets implemented. That's called logic design.
We write Verilog code which describes the hardware.
It's really an abstraction of the gates that will be built. You actually come up with the blueprints.
Then we have our design verification team that tests the Verilog and makes sure it's doing what it's supposed to be doing.
If there's problems, then it gets sent back to the logic team. If the timing's not correct, it gets sent back to the logic team. It's all kind of an iterative process.
As lean and mean as we can make it.
Then we have to implement that, and we implement it physically. Analog design, digital design, standard cell design.
It's really about putting more transistors into smaller space. There's always opportunity for doing something differently, doing it better.
And finally, it actually gets built.
Once we get back an actual chip,
We begin the debugging process on the latest and greatest operating systems.
I think one of the first things we boot up is Doom. Just get a good DOS game going. But that verifies so much stuff underneath the covers.
And if everything's fine, it goes out to production.
It's this energy about problem solving. It's almost like we're fixated on a puzzle.
That's basically what we do. I mean, we're always inventing solutions to problems.